Well, today's video is all about what happens when you simply change the sign of the X or of the Y. And so hopefully by the end of this lesson, you'll be able to see what exactly goes on. And some of this you've already seen before, so hopefully it's not too much of a surprise. Let's first start with Y and becoming negative Y. We know what the original sign graph looks like, or at least I hope you do. Sorry about that delay. Just had to figure out why my markers weren't working. Okay, so there's our sine curve crossing at pi, 2 pi, and of course goes up as high as 1. So what do you think is going to happen when we switch and make that y to become negative? Understand that this could also have been written like this, where I divide both sides by that -1, and it would look like this. This means the same exact thing. Again, you'll notice the whole function is being negated. So in essence, what's happening is your x's aren't changing. So at 0, it's still 0 because, of course, you plug that in. If we were to look at pi over 2, then I would have the sine of pi over 2, which normally is +1. But when we put that negative on there, it makes it -1. And then instead, if I look at the sine of pi, of course, that's 0, and you put the negative on there, it's back to 0. If I then look at negative sine of 3 pi over 2, well, 3 pi over 2 is -1, so then you put the negative on there, it becomes +1. So I hope that's enough to kind of indicate that this parabola basically just flip-flops there. All right, so in the same way, let's look at natural log. Again, having a good base of knowledge here, that this is what it normally looks like. So if instead, and this being the only point there, 1, 0, what happens when I look at the negative form of this? And of course, it's hard to see, but any of these values that are currently negative would become positive. And then any of the positive y's would become negative. 0, of course, doesn't change. And so it would take on that look. All right, so now let's look at what's happened in this next equation. This next one takes us even a step further. Not only is the y negated, but we also notice a switch has occurred between the x and the y. So we take one at a time, and it really doesn't matter which one you start with. Whether you're starting with y equals natural log of x and you switch the sign of the y and then you switch the x and the y around, or you switch it first. Just for to make it a little different than the one prior, I'm going to switch first. In other words, first I'm going to graph x equals the natural log of y. And of course, that is our e to the x graph. And then I'm going to negate the y. And so what that does is any y's that are positive become negative. And so I hope it becomes quite apparent that basically what happens is that e to the x flips down. So what do you notice happens when y changes sign? All right, now with that in mind, let's look at x and changing to become negative x. How does that alter its graph? So back to the sine graph. We already did the sine curve in the previous slide, but I'll just quickly draw that for you. So what's going to happen as I switch the x's? So 0 stays as 0. That's a non-issue there. But pi over 2, so what happens is this now is written as negative pi over 2. We switch that x sign. And so what is negative pi over 2's value? It's -1. And so it would be -1. And then instead of it being the sign of pi, we would have negative pi. And it would take on the value of whatever negative pi was. And of course, that's back to 0. And similar, we do -3 pi over 2. Well, -3 pi over 2 is +1, so it becomes, right, it's +1. So as we do that graph, you'll think to yourself, well, that looks the same thing. And that's only because of the symmetry of the sine curve. So this one's hard to determine what the pattern actually is that's going on here. So let's come back to this next one. If I look at y equals e to the negative x, first again, let's focus on what is e to the x. And of course, that looks like so. What happens to this graph is your x values change sign. Again, whatever it would be at the negative value now flips over and is in the positive realm. So it takes on this effect. Okay, look at the next equation. What does this mean? That negative there, is that applying to the x or to the y? That's the most important distinction in this whole thing, is for us to recognize what is the action that's gone on here. Did we switch the x and the y around? Did I just switch the sign of the x? Did I just switch the sign of the y? And of course, in this one, it's indicating the y. And the reason I know that is because it's applying to the whole function, not simply just to that x. If we wanted it just to the x, it would have to look at the one we just did. So this is saying, I want you to flip in terms of the y. So the y's that were positive, so it originally looks like this, to flip would become like this. And you'd hit at -1. What happens if I change both signs? If we change both signs, not only does it flip to the right, it also flips down. So I'm just going to take it in phases here. So this is the original. It doesn't matter which one you do first. If I did the -x, then that, of course, would switch to be this way. And then, from there, if I switch both of them, and there you go. So, again, understand what happens when you change the sign. And I'm just going to leave this for you to write down for me, for class. What is the rule for changing the sign of the x? What happens? Does it flip a certain direction? Does it turn it? Does it shift it? How does that happen? And what happens when you change the value of the y to be negative?